All right, so welcome to by the end of this lesson, you should be able to identify the different parts of a URL. You should be able to describe things that you can do with the URL, and you should be able to use JavaScript to interface with your URL. Are there any questions before we begin? All right, let's kick some ass. So, I am going to draw out a URL. Oops. Oh shit, it's not. Yeah, that's fine. All right, so there are 6 different parts to this URL. I'm going to put 2 minutes on the clock. You can use the internet, see how many of them you can identify. Go! Another minute. All right, let's see, we have 5 of us in here. We should be able to identify at least 5 of these. Diana, give me one part of this URL.
The user equals 1 is the parameter.
Okay, so this part over here, almost. We're gonna call this is a parameter. The entire thing, starting from the question mark on, is the
Query parameter?
Query string.
Or query string.
So we'll say that that's the query string. User is a query parameter in the query string. Its value is 1. The entire thing is the query string. Because we can do more than one. We can do in ampersand, A equals B. So we can do multiple. It's keys and values, just like a hash or an object. The whole thing is called the query string. Very nice. Mez, give me another one.
The HTTPS.
Uh-huh.
I found actually two things. It's either a protocol or a scheme.
Both correct. So right up to there, we'll call that the protocol or scheme. At this school, we're going to call it the protocol, but scheme is also correct. Very nice. So let's go over what each of these are doing at the end. Samantha, can you give me another part of this?
I actually think I found the same site that Diana found.
Okay.
The 80 is a port.
Good. Very nice. So we'll say 80 is the port. Very nice. Stacy, what you got?
Google is the domain.
There's actually two parts to that. Google.com is the domain name. Okay, but we got that. What you got, Tatiana? Two left.
So .com is actually like the top level domain.
It is. It is. Yeah, we could even make that kind of like a sub part of this. It is technically part of the domain with this, but that specific piece there is, let's see, including the top level domain. All right, these last two. Any guesses? Yeah, Miss.
So mail, I think is a subdirectory?
Not subdirectory. You're real close though.
Path.
Path.
Oh, path, right.
Very nice. So we'll call that the path, and then www,
That's a subdomain, isn't it?
subdomain. Very nice. All right, let's talk about how these all work together to make a request. So HTTPS, our protocol, that's saying this is the format of the request I'm about to send. In particular, HTTPS it's just a bunch of characters. It's not even a string. It doesn't even have a data type. It's just a bunch of characters. But it starts with the version of HTTP you're using. It has the method you're using. It has the resource you're requesting. It has a group of headers. So it'll say something like user agent Chrome. That's so they know what kind of browser you're using. We could say content length nothing, whatever else. And then we say GET requests don't have bodies, but we could also have some arbitrary content that we send along with this. Could be binary, could be a JSON object, could be whatever. But all of these characters are HTTP protocol. That means that if I send something that follows this format, somebody else who says they understand this format should be able to understand the thing I send them. To wit, if I pull up the network tab and go to google.com, This was my request. This is the response that I got. If they send me back an HTTP response, that means that I'm using a browser, I understand HTTP, so I know what to do with this. What's the S?
Secure.
Secure. So the thing that makes it secure is out of scope for our discussion today. But in 2019, other than localhost, there's basically no reason to not use HTTPS for everything. If you would like to, like a deep dive on how HTTPS works, it's pretty fucking interesting. But
Doesn't it just like encrypt any input you?
it does, except it agrees on how it gets encrypted in real time, which is the part that's interesting. So if you look in my knowledge wiki, this is a super in-depth explanation of how HTTPS works. So client tells the server what encryption methods it supports, gives the server a randomly generated number. Server responds to a list of encryption methods it supports, as well as its certificate and a random number of its own. And then they generate public, private keys. Your client validates the certificate through a third party, generates another 48-byte random number called a pre-master secret. So like, holy shit. This happens before you actually make the request. This happens in like milliseconds. Absolutely wild. Yeah.
Post a link to your knowledge wiki.
Oh yeah, sure. And this is like my notes on all kinds of stuff. I've got lots of dev topics in here. I also have lots of just general like business topics or some notes on education stuff. I'm an amateur economist, so I've got some economic stuff there. Design things, some agile, a little bit on data, and audio engineering.
What's the difference in the colors?
Some of them I have I have like placeholders, but there's no thing that's actually links to. Cool. So that's HTTPS. That's the protocol. We're just agreeing on a communication mechanism. So the next most important one is probably the domain. This is a shortcut. Anybody know what it's a shortcut for? Let's take a look at that Google request again. The shortcut for an IP address. Underneath every single one of these domains is an IP address. Google's is 172.217.11.228. Was that? Probably not. See, .228. If I do it again, let's see if it gives me the same one. Yeah, give me the same one. But Google is big enough that it probably moves around a little bit. Not all of them do. Some of them are very much static. It also has the port that I'm using on here.
What is the port for? Is it?
Great question. So let's talk internet a little bit. This has an IP address. This computer has a different IP address. This one has yet another IP address. So if this computer wants to, or this node of the network, I guess we'll say, wants to send a message over here, it looks up this IP address, this computer speaks HTTP, so we send an HTTP message to that address. This computer can also send messages to this computer, can also send messages to this computer. What is fucking crazy about this, so this is the internet. The thing that makes it the internet and not just a net is each one of these can have little networks of its own. This. So is a network of networks. These computers talk to each other through these nodes on the network. Here's the wildest part of this, by the way. Let's say this computer on the network, it can have the same IP address as something on the wider network. So these two are the same. Doesn't matter. Because this computer can only talk to this computer via this node. Can't do it directly. I can't go from this computer to this computer. So when they're sending these messages back and forth, they send them to specific ports. Because let's say I did want to send something to this particular computer on this network, or this particular computer on this network, or this particular computer. I could say, all right. If you send to this IP address on port 80, that computer's going to get it. This guy knows how to traffic cop a request from port 80 over here. Meanwhile, if you send a request to that on port 81, that might send it to this computer. Or it might send it to 4053. That's this computer over here. Yeah?
What determines to what port you're sending it?
This, couple things. Your browser will pretty much only make requests externally to 80 and 443. That's HTTP by default. HTTPS is 443. So if you're using HTTPS in your browser, it sends it to 80, or HTTP, it's to 80. If you're saying it to 443, if you use HTTPS, it does that. Or you can specify it, like we do with localhost. You just do it with that colon. But if I try to specify the port on here, I'm pretty sure my browser will shut me down. I'd say google.com 443. Oh no, it just took it off. But it's fundamentally the same thing.
Is there a name for this thing that controls port?
There's a name for the thing that traffic cops which of these are allowed. You might not accept requests on a particular port, or anything that comes to 81 goes to this computer. And that thing is called a, wait for it, router. And this is a little bit mind-blowing also. This building has one router, one IP address. We could tell that router, if a request comes into 4053, send it right to my computer. And my computer will be listening for any request, and it will respond appropriately. That's what routers do.
Same things that our internet routers at home do.
Exact same thing. In fact, if you pull up your router at home, you can see how you configure all these things, because you'll have a local IP address. It's different for every router. If you're using a D-Link router, then it's one IP address. If you're using a TP-Link, it's a different IP address, but they usually have a default IP address that everything from that brand uses. And if you type that into your browser, it'll log you into your router. And you can like set, this is called port forwarding when we do this kind of thing. You can manage all that yourself. It's pretty cool.
So what is the rules for decisions? Is there like a HTTPS, HTTP port, or is it like a load on the?
Great question. Completely configurable. So for like your home stuff, without setting anything up, you probably have port 80 and 443 shut down, because otherwise you'd be using your home network as a server. If you're accepting requests on 443, you go, okay, cool, where do I send these? You can do this. I do it at my house. I have a little Raspberry Pi that I run a web server on. Yes, you could totally do that. You could open up these ports and redirect them to that IP address on your network and have that respond. It totally fucking works. It's awesome.
So if by default your internet provider bans that?
It'll either ban it, or one of the things it'll do is it'll constantly reassign you a new IP address. And so it gets difficult to go like, oh, go to this IP address on this port. Oh, wait, they changed it. So you can pay 5 times as much for a static IP address, and you'll get one that your ISP won't change. But they know what you're doing, and so they charge you a lot more for it.
Oh yeah, I'm not gonna complain.
Now, there's also services, we're way off the rails now. There's services that they're called like dynamic DNS. No IP, there we go. So what this does is you sign up for an account with them, and they monitor like your IP address changing. And so you end up routing through their service, and then they send it to whatever your dynamic thing is. It's slower, but like if you really want to play around with networking, that's what all this stuff is. It doesn't have anything to do with programming, but especially as a web developer, I've never regretted learning something about how this stuff works. It's also how like a great use of like how you can abuse these ports for fun and profit is like Heroku, Firebase, Amazon Web Services, all those kinds of things. They don't have a different IP address for every server you make through them. They have one, and then they have 50,000 ports that point to all the little different boxes on their network that will deliver up your site. Pretty fucking cool. All right, so that's ports. Ports is a way that we can send a message to a router, and at that router's discretion, it can say, cool, well, 5043 maps to this computer in my network. Or if this is a web server, it'll go, cool, you send it on port 443, this computer is handling web traffic on my network. So I'm gonna send your request over to them. Oh, looks like you're asking for an HTML page. Well, here's their response. And it sends it back to whoever asked for it. Okay, so this turns into an IP address. That's a node on that network. The port is it has to have a port. We have some defaults, but we can also use that to redirect to specific parts on whatever that destination is.
So that's just usually hidden.
Yeah, there's no reason a user ever needs to see that other than a developer. So, all right. Now, let's talk about subdomain. That's kind of interesting. Subdomain is on the same computer that handled this. So I found the IP address. It got sent to the right thing. These subdomains, these are big groupings of things. They're usually different. Like we send it to this, and this thing maybe traffic cops everything with mail.google.com over here, and everything with search.google.com over here, and everything with, so we're looking for like big families of things. We can configure that however we want. That's like that's the thing that we set up once it gets to the computer. But the key difference there is that things with two different subdomains count as different domains to your browser. So cookies don't carry over, like saved passwords don't carry over. So it's a way to hint to the browser that these are two fundamentally different things, and you shouldn't try to like cache resources between them or anything like that. And like that makes sense, right? Because if I have denverflatironschool.herokuapp.com and you have Stacy's awesome site.herokuapp.com, we don't want to share cookies between those. That could have like personal information, all kinds of other shit. So those shouldn't talk to each other. So subdomains are a way we can use that. And www, like despite being this like universal part of our lexicon, is just another fucking subdomain. It doesn't do anything special. Could just as easily be mail.google.com. And since it doesn't do anything, increasingly people just leave it off. Also, pro tip, if you're dealing with a site that like seems like, no offense, a student maybe made it, and you're like, why won't it load? Try taking the www off or adding it and see if it changes, because you have to configure them specifically when you're setting up URLs. All right. Path and query string. Path is, we've gotten to the right computer, it's handling the thing. This is just information for your server on what particular resource it should find. If it doesn't have, like traditionally this is like literally folders. We're looking for, all right, I found the right computer, I found its web folder. I'm looking for a folder called mail. I'm looking for a folder called mail, and inside of that, a folder called whatever the fuck, and a folder inside that called whatever. So that's traditionally how that works. We can also just make stuff up, which is kind of what we're doing in Rails and Express and Node and all that sort of stuff. It's just instructions on what part of this application should handle the request. And then, lastly, query string is data that we want to give whatever that resource was. So we've worked with things like /users. This should give us a list of users, right? Or /users/1. Maybe that gives us a specific user. But we configured the application to read this path and route to the right part of the application. And then the query string, the thing that's different is you usually use a query string to modify a request. So example might be, I want a list of users, but please limit it to 10. I don't want a billion users back. I only want the first 10 that match. So filtering, that's a really good use case for a query string. Or I might say limit 10 and sort ascending. It's like specifying a format you want it back in. Those are the sorts of things that we do with query strings. It's data. Now, we can also send data in HTTP request bodies. The difference is I couldn't put this in a request body and then send you a link that would give you the same thing. That's the cool thing about query strings, is if I copy paste that and send it over to you, you also get limit 10 sorted by assorting, sorted by ascending. Dope. So that's a crash course on URLs. What questions do you have?
What's the difference between query parameters and query strings?
Query parameter is like an individual key value pair. Really, I think it's just a key. The string is all of them together.
So it's all key value
pairs.
Correct. Also, like key value pairs, we think of that in terms of like programming and hashes and objects and that sort of stuff. The reason it's a query string is that the entire URL is just a string. There is no actual like key value pair. That's a thing that can be parsed into, but ultimately it's just a string that gets parsed that way.
So here, like, the key value pair would be like user and one.
Yep.
And then in the one where you were like, it's like limit 10.
Yep. You can think of that as like we're giving it a hash that has key value, key value. What else?
If you've got more than one query,
Mm-hmm.
within there, and you do the windows.location.search,
Mm-hmm.
it separates it out by like the keys, correct? So you've
Correct.
got like ID, and then that's how you grab it in the back end.
Exactly. It's just like an object or a hash where like we can access a particular key and get its value. Great question. What else? Next, you're going to prove to me that you get this. All right, I would like you to write in sentences what this means. Go. All right, so I'd like you to share what you wrote in pairs. Let's do 2 and 2.
You're coming to the end, you have to turn around. It'll be, these desks are really quiet. Yeah, okay.
I said, using the FTP protocol, access the mail subdomain of yahoo.com domain and enter a query string which sort equals send to access that specific content.
and do a query string settings to make sure sorting and setting on it.
Perfect, yeah. You probably got a little bit more specific than me.
Oh, what did you get?
I said that that typically is the protocol, which is.
It does.
I said that too.
Yeah.
Yeah, I posted one and
All right, back with me. We did pretty good on that. So, Diana, what was your answer? I like your answer.
Oh, it was, using the FTP protocol, access the mail subdomain of the yahoo.com domain and enter a query string of sort equals DESC to access that specific content in descending order.
Beautiful, love it. So, HTTP, HTTPS, those are protocols. FTP is a protocol also. POP3, also a protocol. SMTP, also a protocol. There's dozens of these things. They're all just different formats for characters. And as long as you're sending something that the recipient also speaks, doesn't really matter. So let's draw this out a little bit too. So I have my browser. I send a request out to the router. Part of the router's job is to help figure out what the IP address for yahoo.com is. It might just know it. It might need to look it up, like through a service called DNS, which is like a phone book. So maybe it goes out to a domain name server. It's just keys and values also. Yahoo.com equals this IP address. If this one doesn't know it, it looks it up somewhere else. There's a whole chain of these, and it ends up at where it was registered. But somebody somewhere knows what the IP address for that is. So your router figures that out, and it sends your request to whatever IP address that is. So that is also a router. And based on whatever protocol you did, it defaulted a port probably. So it goes, secure traffic. I actually have a computer on my network that handles that. So it sends it to the correct computer. And this might have applications running for mail and search. Goes, that subdomain, this computer is going to route it to this application I'm running. It goes, cool. By the way, they were asking, if you don't ask for anything in the path, it's assumed you're asking for index. So they're looking for the index. Also, they gave us this data. It's like if this is a Rails app, it goes, okay, pull up the index, the application controller's index action, and then make sure that it knows it has sort descending available as a hash that it can do something with. That's the long journey the request makes. Any other questions about what URLs are made of? Dope. So, we've talked quite a bit about what you can do with these also. Do you have questions about what you can do with URLs? big thing I want you to remember about this is that query strings are also part of the URL, so you can copy paste them and send them to people. And generally the stuff that you put in here is stuff that modifies whatever request you're making. So it would not be appropriate to set the resource you're asking for in the query string. You could, that would work fine. You usually want path to be the resource we want, and if we need any additional information to narrow or format or whatever the response we get, that usually comes in the query string.
So if there's more backslashes, it's just.
All part of the path.
Into the path.
Correct. So, let's talk about how we work with this in JavaScript. There's 3 objects that I want you to just kind of generally be aware of. Document, window, and navigator. These are 3 global objects in browser JavaScript. You've used document quite a bit in this mod. What does document do?
It adds something to the document of HTTP, or I mean, sorry, the HTML.
It's even bigger than that. It is the document. Our HTML is just a string. This is, if you haven't heard this yet, then consider it the first of 1,000 times over like the next umpteen weeks that you're going to hear this. HTML is a string. HTML is a string. HTML is a string. There is no hierarchy. There is no tree. There is no nested anything. HTML is instructions for making that tree. Once that tree gets made, HTML gets thrown away. It doesn't exist anymore. It becomes the document. HTML is a string, HTML is a string, HTML is a string. It gets parsed into this object. We also have some cool utilities like create element. Oh no, it didn't come back in the HTML. Neat. Well, you can still modify the document through like document.create element, that sort of stuff. If I want to get a particular part of the tree, I do document.querySelector, document.querySelector_all. I have those things available also. All that stuff is relating to that hierarchy, that tree. So if I just look at what's in here, hey, it's an HTML document. It's got its URL, has its children. This is that entire tree, HTML. Head, body. There's the body. Does it have children? Style tag, style tag, style tag, div, text area. That whole HTML thing we wrote got parsed into this, and part of what a browser does is it takes this tree and knows how to make it look a certain way. Yeah?
So, what's the difference between document and the DOM? Like, is it the same thing, or is it just how it's?
The DOM is this entire system. We use the document object model to work with documents. The object model part of it is that, so I'm in the body here, an a DOM element shall have an access key attribute, a background attribute, a base URI attribute, and all children in it shall be stored within the child nodes thing. But this predictable structure, that's the DOM. But when I'm fucking around with the DOM for a page, I'm fucking around with the document. Great question. All right, so that's document. Next one, this one is not appreciated nearly enough, is navigator. Navigator is the device that this is running on. And there is some cool shit you can do. For example, you can access the clipboard. Like your copy pasting stuff, that's available to you. Your location. You can get somebody's physical location through the geolocation API. You can read whether or not something supports touchscreens. There's all these cool permissions in here, service worker, storage. You can read the user agent, which is your browser. Down here in the prototype, I saw one on here for vibration. If you're on something that has vibration enabled, you can trigger that with JavaScript. Let's see. Yeah, this here it is, vibrate. So this is stuff with the whatever device you're running it on. So you can either detect features or use those features.
So it's not just used for like a computer, you can also use it on like.
Phones, anything that runs a browser. Or like this one, this has like demonstrations on how to use cameras in JavaScript. Oh, it's a web page, and I can do things like take a picture, and it shows up right there. Or there it is. I can even record video on this, and it'll try to save that for me. And the thing that enables all of that is Navigator. So you read the cameras and stuff. Yeah.
So when we, in our like JavaScript, when we go like document, here's like, can we do the same thing with Navigator? Like we want to get into our clipboard for some like crazy reason, we want, like, can we do like Navigator dot, like, you know, query selector? Like,
Sure. It's a similar kind of thing. With a lot of these, you have to ask permission for obvious reasons. And so like in this function, if this has media devices, so microphones and cameras, if it doesn't have it, then I want to show this error. But if it does, I want to list the devices that I have, and then I want to get only the cameras, and then I want to display the list of cameras to the user so that they can click on those, and then it's going to ask them for permission. So like, let's see where the permissions thing is. Somewhere in here. But if you want to see how you could do this, check out Web App Kitchen Sink. The guy who made it is a handsome genius, but it's annotated code for how you would do something like that.
If you're building like mobile apps, are you using Navigator a lot to stuff?
Yeah, because you can access those APIs that, and this was like the big shit for a long time is they go, oh, well, web apps can't use all the accelerometer and all these. They totally fucking can. They have for a long time. But people don't assume that. So they think they need to make a special mobile app. And a lot of times they don't. They can just access it through browser. So that's Navigator. And then the last thing I want to show you was Window. Window is special in a few different ways. Window is, that is what we call the global container in JavaScript. If I do something like A equals 2, so hopefully you figured out by this point, I should have used var let const, some kind of scoping thing on that. But if I didn't, I wonder what window.a is. 2. They all just end up going on that object. That's thing number one that window does. The next thing that window does is gives me access to things like inner width. Huh. That's how many pixels wide this is.
so your window is like your current screen, basically, like the thing you're seeing.
Viewport would be the correct term for it, but yes. Also keeps global JavaScript objects and gives us access to stuff like this. It's like window.location. What's on this? Oh, neat. I can access the protocol. I can access like what was entered in. I can access the host name. The host is subdomain and domain together. I can get the path. Get all that shit.
So when you're using in CSS, like
Mhm.
percentages, does it like automatically then grab like the window inner width or something to like calculate?
Does it through a totally different system, but yes.
So if we change the size of your like dev over here,
Yeah.
are we literally talking about the window that you're looking at? It'll change your window size.
Window.inner width. Oops.
Yep.
There you go. Indeed. So when I'm doing redirects, I can read window.location.href. I can also write to it. So I could say window.location.href equals mail.yahoo.com, and it, oops, you see what it tried to do? It tried to make that the path, because I didn't, it's not as forgiving as browsers tend to be. It wants to know, all right, well, what protocol, etc. So if I do that, it takes me Yahoo.
So kind of.
Yeah.
So when we, in our like params on the show
Mm-hmm.
series, when we do new URL search params and we do window.location.search, the search is like, that's the actual query params that we're putting in there?
Yeah, so I have a ton of them right here. Let's read those. So if I do, let's see, it was window.location.search. Okay, so that gives me that, just as a string. That's the literal query string. All right. Now I also have this, let's see, I'll put this in query equals new query. Isn't that what it is? Is it params? URL search params.
URL search.
Okay. So this is actually pretty new. We used to have to like just break this apart with like regular looping and JavaScript and stuff. Suck. Now I can pass that in. Window.location.search. And now I have this query. What can I do with it? Huh. So I've got get all, like that. Do query dot get all. If I run that. Oh, probably want something specific. So what about dot lang? There we go. We do .intl. I'll bet get all, does this return an array? Yeah. So the, there are totally valid reasons to do this, but you should know. You can also store arrays in this format. You basically reuse the same name multiple times and put square brackets after it, and it will let you store those in an array. So like, get everything that had this key, and it'll return those back as an array.
That's really cool.
It is really cool. And you guys didn't like JavaScript a week ago. Cool. What else do you want to know?
This is like exactly what I wanted to know, because these are like the 2 lines that David was like, yeah, these are just like the 2 lines you need to know to make a show query. I'm like, okay,
He's right.
What do they mean? I don't know what they mean.
All right. Well, now hopefully you're a little bit clearer on what they mean.
Absolutely.
Good. Anything else? Thank you very much. Have a good lunch.
Thank you.
Thank you.
You're very welcome.